Hello everyone. Today we'll continue to talk about streaming using Grid Free. Last time we finished talking about the idea, the major approaches. This time we'll take a look at at the code. Okay, let us open this code. Code here, streaming. You can find the code here. The latest version is already published on my this is my video on YouTube, and you can see here this is my GitHub website. You can get the latest version. Latest version is 1.3.0. This is the latest version. You can get the latest code from this directory, and this is all the directory, and this is the project. I just upload the latest version to GitHub. If you're interested in, I hope you can connect with me. I think we can exchange ideas to improve the important project. We can start from here. You can see this one name streaming broadcast, right? So we can start from the root. Last time we talk about this is the first approach. The first approach is called polling broadcasting approach. Using this approach, the registry information need to be accessed through polling, and broadcast indicate that the stream is based on the multicasting based on the broadcasting in the multicasting framework. Okay, let us take a look at this code. Okay, this is starting point. All the distributed system in my system, if you're using Grid Free to program your system, the starting point is the same. So we can skip this code. Keep going. Okay, peer. You are familiar with peer, right? Because now we need to the root. You can see, if you forget, you can take a look at the overall structure. Okay, this is the structure, this is the root, this is the root. Okay, this is the root. Okay, this is root. No, root is the multicasting framework. Is a data. All the data should be start from here. The stream also start from here. So let us take a look at the root. But you can see, because this root is hierarchical, the top of the hierarchical structure, there's no difference from what we have seen before. So we can talk about this issue quickly. Okay, this code is easy to understand because we have already talked about that in previous class, the class 7. We already talked about that. This should be class 8, right? We already talked about multicasting. So you can see the peer, the root multicaster, and some initialization tasks need to be performed here. Okay, let us take a look at this root master. Okay, it's the root clan. You're familiar with that, right? We talked about that in detail in previous classes. Okay, next. Okay, let us take a look at this one. Dispatcher. Dispatcher is very important because it provides concurrency programming. The concurrency is supported by dispatcher. Okay, let us take a look at the message. The message The first one is streaming notification. Stream notification. What is stream notification? The stream notification is actually send. Let us search. Perform a search. Okay. You can see here. There is a publisher, right? This is the publisher. Actually, publisher, what is a publisher? Publisher is here. Publisher is implement on CS client. So that means streaming notification is originated from the publisher. Publisher means this is the author. All the data is created by publisher. The publisher is the data source for streaming. So publisher send its data through stream notification to the root, and the root is responsible to transmit this data within the hierarchical structure, within the multicasting framework, using multicasting, because we now talk about the polling podcasting solutions for the streaming framework. Okay, let's continue. How to do that? I think you can understand it. It's easy to understand. Okay, you can see here. This is the thread. This is thread. This because this notification. Let us take a look at what it looks like. Okay. This is the data to be broadcast. I call it stream data. What it looks like. Okay, the publisher, topic, and the content. Content may be the data. This one is represent the type of the data, the category of the topic, and some preference. The user can search. This is the author publish such kind of information, and the readers or the subscriber who are interested in this topic, they can find this topic from the pub sub registration registry framework, the pub sub server, right? Publish a subscriber server. They can users, anybody, readers or subscribers can find such data according to publisher and the topic. This is the content is the exact data. So it's easy, right? It's easy. It should be serializable. And this is a notification. What is this? This is a child K. What does it mean? You can take a look at this. You can see here. This is a notification, right? Notification is obtained, and then here one. This method you must have never seen such a method. So let us take a look at this one. This one method select one child K randomly from the multicasting framework. Why do we need to do that? Because we talked about that before. So because the data is multicast to all the children, so all the children, not multicast, broadcast to all the children, so all the children have the same data from the publisher, right? All the children here have the data from the publishers. All the data have the same data. All the data is replicated to each of the children. So if the children need to do something, because stream exists in this multicasting framework. However, a lot of subscriber need to access such data. At this time, because broadcasting is used, so all the children are the same. All the children in terms of the data, right? All the children are the same. So only one children only one child need to be selected to perform broadcasting for all the subscribers. So which children is selected? Here we selected randomly. In practice, maybe this is not a good solution, because in practice, you need to measure the distance between the subscribers and the children. A lot of children, right? You need to find one children that is close as possible to the subscribers. However, because we focus on the distributed framework, so at this time we do not talk about that. We just select one child from the multicasting framework randomly. Okay, so the K is displayed here, and the K, the select K, select child is set. So the information, the data, within this notification, we need to have this K. So because only one child is selected, so the child that match this K is responsible broadcasting the data, broadcasting the stream to all the subscribers that are interested in one specific topic and the publisher. Okay, that's why we need to do that. In the previous classes, we do not need to do that because it's just perform broadcasting. This is stream, so we need to make some changes here. Okay, what about this? What about this? Broadcasting notified. That's easy to be understood, right? So data is broadcasted. Okay, so this thread is finished. We do not need to talk about this one. Okay, this one is easy. Okay, this is shut down. Doesn't matter. Shut down. It's the same what we had done before. They shut down children. It shut down the server. The root server here is the root. So the code is easy, right? Okay, should be fine. Okay, so the root is very easy to be understood. All the code, we finished all the code here. So next, let us take a look at publisher. Okay, maybe you are interested in this code. Not publisher, pub sub server. That stands for publish subscribe server. Okay, so now this one. Okay, this is server, pub sub server. Okay, this is actually is a kind of registry server. Open it. Okay, easy. Different from this one, we have another registry server. I'm not sure whether you still remember it or not. Another one is here. You must be familiar with this one. This is registry server. When we program the peer-to-peer system, when we program the multicasting framework, when we use this registry server to keep the IP address of all the peers. In this case, there are a lot of distributed node implement on peer, subscriber, and all the children, and even the root. So all this is registry server. We already know about that. Now we talk about this node, this distributed node. This is the publish subscriber server. In this time, we implement it on peer. Different from that, right? This is the implement on server. Let us take a look at this. Okay. Usually, it's a registry server can be implemented using CS server. However, this time we use pair instead. This is a things we have another approach, right? In the later case, we have another solution. In another solution, this REST server is able to forwarding some registry information, necessary registry information to the children within the multicasting framework. So for this case, this is the first solution. We use polling. So if we want to use another approach, it's better we use peer rather than self-server. So you need to consider there are differences, right? There's some advantage and disadvantages. You need to determine which one you need to use to create your registry server. For this time, I use peer. Okay, let us take a look at this. Okay, this should be easy. Oh, this one is not necessary. This one is not necessary. It's an old code because I changed. Okay, you can see they're not necessary to have such code. Because I created this code in 5 days, so I found this problem. This is the bug. It's not necessary to use this one. Okay, I just comment it out. Okay, you can say I always keep change. Okay, take a look at this one. Open this publisher. You can see a lot of message need to be implemented, or a lot of message should be processed by the pub sub server. First one is add stream. Add stream means someone want to a new data source is available. A publisher need to join such a system. The publisher want to publish new information, a new topic. If so, he need to send such information to the pub sub server. Let us take a look at this. What is it? Okay, you can see in our case, the stream is represented. One type of stream is represented by a publisher and the topic. So if new stream is available, the publisher need to send such information to the pub sub server. Okay, so you can see the publisher. Okay, publisher sends such information, right? Okay, after the this notification is received, the stream is added to this registry, right? That's very important. You can see here there is a registry because pub sub server is a type of registry. It's similar to this registry server. However, it's an upper level. It's an upper level registry. Another this is registry for stream. This is registry server for the IP address. Is a low level one. Okay, let's take a look at this. All stream are put here. In addition, we have IP addresses. Why do we need to have that? Let's take a look at this. Well, a stream is added here. Okay, stream. This is a class to represent one stream. Okay, within this class we have topic and the publisher. In addition, we also need to define a field, a list. All the subscribers need to be kept in this class. So if we need to know which subscribers are interested in this data, we can access this registry. We can access this registry and get to know the registry information, the subscriber information. Okay, we can also remove if the publisher are not interested in this topic. It want to remove all the data it published. Then that means it never interested in such data. It never publish such data anymore. Then they can remove such stream. Okay, this is remove, right? Remove. Okay, that's easy to understand, right? Okay, next. Subscribe stream request. What is it? What is this? This is, as you can subscribe stream request. That is that search. You can see here. Subscriber send to such information. Subscriber send this request to the publish. Subscriber can see here. Subscriber need to send such need to have a connection, right? This is the direct connection. So subscriber need to publisher need to add a string or remove string. The subscriber need to subscribe one string. Okay, so this is the data sent from subscriber. After such request is received, if such is received, then what else? Then you can take a look at this. Then it will check why the such stream is available or not. If so, this subscriber will be added to the registry, right? To the stream, right? We just see such a class. So all the subscribers are registered for on one particular stream through this request response. Okay, next, unsubscribe. That is easy to understood. This is the reversed action behavior, right? With perform subscribe, maybe the subscriber not interested in this stream, then they can perform unsubscription. They can send unsubscription information request notification. This is notification to such system, right? And then the subscriber will never receive such information. And then what else? This one. Subscriber's request. What is it? Subscriber request. Let us search. Oh, that's here. You can see here. Subscriber receipt. First, the child, you can see child need to interact with the child, need to interact with the publisher, not public, the public subscriber server, because all the children need to interact with the publish a pub sub server. That is the child need to access the IP address of all the subscribers, right? So that things the children, one of the children in the multicasting framework need to broadcast the data from publisher, need to broadcast the stream to all the subscribers. So it's necessary for this, for the children, know the IP addresses of all the subscribers before the broadcasting can be the broadcasting between the children and the subscriber can be performed. So the randomly selected child in the broadcasting framework need to know the IP addresses of all the subscribers. Okay. Before, if not, the broadcasting between the child and the subscribers cannot be performed. That's why we need to do that. Let us take a look. Let us take a look at this. Okay, you can see here this message, we need to detect. Whether this message is all. What does that mean? That means you can see here, not only the child need to access the POP subserver, the clan. What is a clan? I use a different term here. This is a clan. Now in this diagram, I call it user. The clan actually is a user. Because I use another term. It doesn't matter, right? Why the clan need to interact with the publisher? Well, okay, I missed the one connection between the user and the pub subserver. Actually, that's necessary in this case. You can see here, this is the clan. The clan need to send a request to this pub subserver. Why? Since the clan, you can see clan need to interact with the subscriber, right? This is the application, upper level application. This is the end user, the consumer of the stream. So subscriber is available, but which subscriber provide services for all the users? The user is the CS clan. So how to perform such service, provide such a service to this user? Only one subscriber is needed to be selected. So in this case, you can see this is false. What is it? This is false, right? False, that means it's not all, not only one, that means. Okay, so you can let us take a look at the code on the pub subserver. If all the subscriber for one particular stream, it need to be returned. That is usually that message is must send from the random selected child, right? So because the randomly selected child need to know all the IP addresses of the children and of the subscribers. Sorry, of the randomly selected child need to know the IP addresses. So this one, if all the children and all the subscribers need to be selected, this request must send from the child. Let us take a look whether it's true or not, right? You can see here, this is the constructor. For this constructor, there are no we do not need to necessarily set is all the Boolean value. If so, the Boolean value is set to true. However, for this constructor is only accessed by the clan. So this one is set to false. If this one is set to false, that means only one child need to be selected. So only one subscriber need to be selected. So for example, if this one is selected, this one will interact with the child using request and response. This is a typical client-server model. So only one subscriber will be selected to deal with, to perform the accessing, to perform the services, stream services for the user, for the clan. Okay. So this one is sent from the this response is response to the random selected child. This one is respond to the client that interesting one particular stream. Okay. Next. Stream requires stream. What is this? Stream. Let us check. Stream request. Stream request. You can see here, right? This subscriber. You can see here the register stream. What does this one is not so important. I just want to display all the register stream and show it on screen for the subscriber. You can see such case, I will run this code later. So you can see here. This is subscriber. So after this request is sent to the pub subserver, all the register stream are displayed on the screen. Then, according to this information, the subscriber can select one of the stream that he is interested in and then perform subscription. Okay, that's why such information, such request is necessary to be. It's just not so important. This one is the code that want to help the subscriber know which how many not what exact stream are already already added on the register on the pub subserver. Okay. Until now, you can say this system, this pub subserver. Until now, although I finished talking about all the code, you must already understand. The code is same, although application is difficult, right? This system must be the most difficult one until now, the most difficult one we talk about in this class. However, you can see no new distributed API are employed. All the API we have used at this time are all from GridFree. Okay, right? All from GridFree. We do not use any third-party distributed APIs in such a project until now. Okay. Now I think it's necessary for us to talk about the child. Child is also important, right? This is the child here. Child is different from the little bit difference. This child is different from what we talk about in the previous class. In the previous class, we talked about the multicasting framework. the child only need to for receive data. The child is one of the distributed node in the multicasting hierarchical structure, and after data is received, it's just a forward, and it also need to perform some need to, maybe this is one of applications that need to process the incoming notification or request. After that, this message also need to forward it to its children, right? If the such a local child is intermediate one in the hierarchical structure. And more important, however, in our case, that's a little bit different, because here the child has different role. First, the child is for this one, you need to forward the data, right? In addition, this child may be selected to perform multicasting, right? Since there are a lot of subscribers need to access the stream the child received. Okay, so that's a little bit different. This child has the two roles. First one is the children in the multicasting framework of the stream. Another role is that the child is possibly to be the root of a new multicasting framework for the subscribers. So because of that, you can say the child multicaster, the child multicaster and the root multicaster, we need to define both of them. This one is used as a for the multicasting framework. This one is used here for this multicasting, for this hierarchical structure. However, this one, what about this one? This is root, because it's root. This one is here, right? Since the child, if this child is selected randomly, and then this child is responsible for broadcasting between itself and the subscribers. Okay, so we need to define this one. Right? This is straightforward, and not difficult to understand, right? Okay, so need to perform initialization. So this code should be easy to understand, right? Okay, let us take a look at the dispatcher. It's easy to understand. Okay, this is root IP address. This is the same, but actually in this case it's not so important at this time. Now maybe we can remove it, and doesn't matter things. For this case, this is streaming. This multicasting framework construct streaming. So only notification exists in this hierarchical structure. No request response, no multicasting request and multicasting response is implemented for the streaming based framework. If so, the children just perform forwarding. No, it's not necessary to send a response to the random point. So here, random point is root. So here, this one is not necessary. It doesn't matter. We just put it here. Stream notification. We see such message before. This one is should be transmitted from the root. So after this one is received, the child need to first the child need to forward. That's fine, because this is broadcasting. This is broadcasting, right? This is broadcasting. So this is the first task it need to perform after this notification is received. It use a sync notification to read the performance, right? Next, I need to detect whether this notification, the stream notification has a key. This is the child key selected by the root. I need to detect whether the child key is equal to let's select a random key or not. If so, that will be important. If so, it will reset the children. Reset means maybe the subscribe. This is the selected child, right? If this condition is fulfilled, that means this local child is selected. It's selected for the broadcasting for the subscribers. However, so the subscribers are the children of the local child. So I need to say set child. How to do that? First, you need to access the pub server, right? This IP address. How to get this IP address? You must be able to answer this question. This IP address must be obtained from the registry server. You can, no problem. It's easy, right? You can say this IP address is obtained from the registry server. So if this IP address is obtained, then the child can interact with the pub sub server. Okay, so then they can get all the subscribers for one particular topic is obtained through the interaction between the child and the pub sub server. And then what else? Then this one need to, because the IP address is necessary. In this case, the IP address is not IP address is saved on the pub server, right? And not pub server. The IP address is saved here. So this IP address should be accessed. In this case, the IP address is accessed from this server, retro server. So one new data, that means one new stream is received. This random select children need to access the publish server first, pub sub server first, and then access registry server next for each new received stream. So that means polling. This polling will be frequently performed because they need to do that each time. One new data is received. So the burden, the workload is heavy. The workload will be heavy, right? We talk about that issue in the previous class. This one is called polling broadcasting solution. This is not. Each solution has its advantages and as well as disadvantages. We talked about that before. For this solution, each time you need to access the registry server. So the registry server will get heavy burden workload. The advantage is that this is disadvantage. The advantage is that the local node, the children are not required to keep the registry information. It saves some storage. It saves a lot of storage computer resources. Okay, so you can understand this such system. It's a okay, no problem. This is easy. For this case, the child is very easy to be implement. It's we just again you can see that we just use grid free distributed API only for such complex system. It's Kafka-like system. Kafka is very popular, right? However, we can implement the Kafka-like system easily, right? The straightforward is not difficult to implement such a system. Okay. This is a chill. So next, let us take a look at subscriber. Subscriber is here. Okay, subscriber. Subscriber can here you can subscriber also implement on peer. Also implement on peer. Let us start the subscriber. Okay. This peer is started here. That is for this code is easy, right? This is just the interface. So some interaction interface is in the terminal, so we do not need to care about this code. It's easy to understand. Okay, here maybe this is okay, just open this code. This code is the most important one for subscriber. Okay, peer, right? Peer. Using peer is more flexible. First, the peer can perform all the features of a server. The peer can work the same way as a server. In addition, if you have other solutions, if you want to forward something, then the peer can be used as a client as well. So in this case, although we use peer, it only performs a behavior, play the role at the same as the server. But since we do not want well, no, I'm sorry. Here, no, that different. I made a mistake. This is subscriber, right? Subscriber should only be a peer, since the subscriber need to perform multicasting, right? Since it's possible a lot of subscribers are interested in one particular stream, so the subscriber should be a peer. It need to become one distributed node in a broadcasting hierarchical structure. So because of that, the peer should we cannot use any other distributed node. The server cannot be used here. Client is we cannot use client here, since only peer can be a node in a multicasting framework. Okay. In this case, this subscriber is only a child. So this code is similar to the child we talked before. Very similar to each other. You can see this is child multicaster. The difference is that maybe this child need to perform subscribe or unsubscribe. If one particular topic is not so interesting, then it can send unsubscribed information to the pub subserver. And this one we talked about that before. Okay. Next, open this code. You can see all the data structure, or not data structure, all the code structure is the same. The design patterns are same. We just repeatedly use the distribute primitives, some advanced new APIs that based on the distribute primitives. They also use distribute primitive design patterns. We do not use the code structure is similar to each other, although the distributed system is completely different, right? Distributed system is become complicated, and the system the application also different. However, you can see the code. The code, we already see a lot of code, right? All the code structure is same. The API is same. Okay, that's the important issue I want to talk. Okay. After this stream notification receive, just perform forwarding. This is forward. This is through asynchronous notify, right? This is the same. We talked about that before. This one is multicasting. And what about this? This is different. Since the subscriber need to provide services for users, so it need to keep the data on its local database. Then other users can access the interact with it to access data from such a DB, right? That's why I want to do that. Okay, search request. What is search? That's a new message, right? That is new message. The search request actually is sent from the client. That easy, right? This is a typical client server interaction. That's here, right? Here. So the user want to access the publisher, the subscriber to retrieve data to the service provide by the subscriber, right? The data, because the subscriber already have the stream. Then user can access the data through the request response. Okay. So this code finished. It's not typical, right? Okay, we still have, maybe you want to take a look at the user and the publisher. This is the code we still not talk about, but I think this code is very easy. Okay, you can see only 2 source code fail. This is just a simple interaction manual, so we do not need to talk about that here. However, this one is important. Let us take a look at this. Says client. Then some addresses should be here. One is a pub sub address, another subscriber address. This one, using this address, the client can just talk about that, right? The client can access subscriber, and this app can know which subscriber can provide a service for this client, for this user. And based on using this IP address, the user can send request and response to the subscriber, right? To consume the service. This is search. So this code is very easy. So here you can see set. This is a method set subscriber address. First, the client, this user need to access the pub sub server to get a subscriber. Select a pub subscriber. Then you send another request to the register server to get the IP address of the subscriber, and then it's able to interact with the subscriber to consume the data, the stream. So this code is very easy. Publisher is here. Yeah, publisher is also easy because csclan. It's easy to implement csclan. Okay, csclan, the publisher name. So this is a simple interaction menu in terminal. Okay, let us take a look at this code. Okay, this code is a little bit difficult, but if you have already learned what we talked before, watch all the videos we talked before, it's easy, just csclan. So the publisher need to know the IP address of the root. That's important, right? And then the publisher also need to know the pub sub address. That's also common sense, right? All the IP address can be accessed from the registry server, right? After that, they can add string, remove string, and publish string. When data need to publish, when data stream need to publish, need to interact with the root. Okay, I think I finished all the code about the first approach. The first approach is this one, polling broadcasting solution. In this case, the most important one is the broadcasting is performed in this framework, in this multicasting framework, and then the child need to access the register server, and this is another register server to access the relevant information. That is called polling. So I hope I will show the demo in the next lecture. So this is because this demo is a little bit complete, and I hope you can I can show you next time. And okay, I'm not sure whether you have any questions. In short, you can see such a system. When you look at the diagram first, maybe you think it's difficult to implement. That's true. If you using traditional approach, using the mainstream programming language such as C, C++, or Java, C#, it's very difficult to implement such a system. However, you can see using my approach, the lines of code only 3,881 lines of code. It's a small project, it's a tiny project. However, if you use traditional approach, it's a large project. The lines of code must, I think, at least at 50,000 lines of code, right? It's more than 10 times as what we had done. Okay, next time I will show the sample. I show the demo. I will run such a system. Okay, if you have any questions, just let me know. Okay, that's all for today. Thank you so much. See you next time.